Beyond BIM, better information management. Join the BIM event of the year for the AECO sector. Explore how better information management is reshaping digital construction across architecture, building, and infrastructure. Free and online. Save your spot now.
Hello everyone, and welcome to ConstruWeek 2025, ZIGURAT's annual global event dedicated to BIM and digital innovation in the AC industry. We will now begin with track 1, focused on architecture and building. For those interested in the infrastructure and civil engineering, track 2 will start in 1 hour, okay? So you are welcome to attend both sessions or join the one that best fits your interest. Today, we bring together leading experts to discuss a key challenge: how to achieve better information management in BIM-based projects. Over the last decades, the digitalization of the AC sector has transformed how we plan, design, manage, and coordinate assets. This evolution has allowed us to generate data faster, with higher precision, and at scale. But with this exponential growth of information, the critical question is, how do we structure, organize, and leverage this data strategically? That is the focus of this year's ConstruWeek theme, Beyond BIM, Better Information Management. The idea plays on the BIM acronym. BIM, Building Information Modeling, becomes Better Information Management, inviting us to move beyond modeling and focus on the true value of well-managed information. I'm Thaisa Figueroa. I'm an architect and urbanist, and I work as a program owner and institutional relations here at ZIGURAT. And it's a real pleasure to be here with you today, live from Barcelona, for this exciting event. And if this is your first ZIGURAT event, let me tell you a little bit about who we are. We are a global online education institution with more than 20 years of experience in advanced training. We specialize in master's and postgraduate programs in BIM management, digital transformation, smart cities, and more. Our faculty is composed of active industry professionals, leaders who bring real-world expertise into the classroom, and our community exceeds 20,000 professionals from over 120 countries, making ZIGURAT one of the most international learning ecosystems in the sector. Our first track today, our track 1, is focused on BIM for buildings and brings two main topics: the digital twins for carbon and cost reduction, and also the innovations in AC through better information. Guiding us today are two recognized leaders in the field. We have Vicki Reynolds, who is Technical Director at One Creative Environments, a multidisciplinary design company that brings together architecture, engineering, planning, and interior design to deliver creative and innovative solutions for construction projects. She is also part of the Women BIM, a global organization that supports, empowers, and promotes women working with digital methodologies in the built environment sector. And as a NEMA ambassador, Vicki advocates for the adoption of information management standards in the construction industry, helping to transform the way information is measured and shared throughout the life cycle of built assets. And finally, she is director of the Masters in Global BIM Management here at ZIGURAT, our international online program that trains professionals in collaborative methodologies, BIM, and digital project management. And we also have with us Melanie Robinson. Melanie is associate and strategy lead at Ocana, Consultants that specialize in strategy, transformation, and digital innovation to help organizations in the built environment sector achieve sustainable growth and deliver better outcomes. And she's also serves as a regional lead at the Woman in BIM. But before we begin, a quick note. The track 1 is related to our Masters in Global BIM Management. This is a 1-year, 100 online program designed with a practical, market-oriented approach. The next intake is in November 2025, so there is still time to you to join and take a decisive step in your professional journey. So for more details, feel free to scan the QR code on the screen or follow the links that we will share in the chat, okay? And another note is during the session, please use the chat to submit your questions and insights. We will dedicate a time at the end of this first track to this Q&A part, okay? To answer your questions and your doubts. So let's get started without further delay. I give the floor to our first speaker, Vicki Reynolds, and after her, we will hear from Melanie Robinson, okay? Thank you, Vicki. Thank you so much. The stage is all yours now.
Thank you so much, Thaisa. As I've been introduced, my name is Vicki Reynolds, and I'm just going to share my screen 1 second. There we go. I hope everybody can see that now.
Yes.
Brilliant. Excellent. So I'm going to talk to you today about digital twins for carbon and cost reduction. And, oh, there we go. As I've already been introduced as, I am the director for the Masters in BIM Management. I won't go into it too much because we've just had a wonderful introduction there by Thaisa. But I'm also the technical director for One Creative Environments. And as already introduced, we are a multidisciplinary consultancy with arms in smart assets and digital estates, which I'll explain more about in a moment, BIM, architecture, engineering, interiors, landscape, and we have a software platform called One Engage for building safety and fire safety. We've got lots of certifications and we win a lot of awards, which we're very, very proud of. And as you can see at the bottom there, we are a very diverse and fun group of people. It's a really nice, enjoyable place to work. So Digital Estates, that is the team that I am a part of, and we are a software agnostic digital twin consultancy, and we configure digital twins to optimize assets and improve estate performance. So what we do is we look at clients' pain points, we look at what they already have in terms of software, solutions, IoT sensors, data points, and we come up with a strategy to pull all of that in for visualization, automation, reporting, alerts, and build them a bespoke solution. We're not a software vendor. We don't produce any digital twin software. We have a range of different partners that we work with to configure and build customized solutions depending on our clients' needs. So every solution that we create looks completely different. So for anybody who's not completely familiar, a digital twin is a bidirectional connection between a physical and a virtual environment. So what that means is a physical environment has data pulled into a virtual environment through sensors, through other data points, and that virtual environment then uses that data to analyze, replicate, simulate, and automate. And the outputs of that then push back into the physical to create change. So as you can see, there are multiple different data points that we could pull into a solution like this to provide all kinds of different insight and automation for a physical building. And what that looks like in terms of architecture is something like this. So pulling that data in from the fields of devices and from the systems into a cloud service to organize and structure that information, which then is pushed through a data adapter into a digital twin solution where we can create bespoke algorithms, UI components that are completely bespoke so that they show what needs to be seen by who, so we can produce reports and solutions based on specific users, and we can present information in graphical or non-graphical formats. Now, when I say we, I mean digital twin providers. I'm not just talking about One Creative here. This is ultimately the architecture of a digital twin. So the best way to describe the opportunities for carbon and cost reduction is to run you through a couple of case studies. So the first case study we have is actually our own office at One Creative. This was the proof of concept for us for the digital twin idea and the digital twin business unit. So in 2022, we faced rising energy costs and a £40,000 annual energy bill. We identified the need for greater insight into our energy consumption to be able to reduce that cost. Now, we're not a huge office. There's probably about 100 people maximum in there at any one time, and that would take it to complete capacity. So a £40,000 energy bill is absolutely insane. So we had a building management system, but it didn't have the granular data that we wanted. So we couldn't measure individual outputs like lighting, small appliances, the air conditioning per room. So while the intent and the need was there to monitor specific energy outputs and usage, the tools weren't. So in 2023, to establish a baseline for improvement, we created a digital twin to obtain granular data. So we installed sensors throughout the office to collect data on energy usage, temperature, air quality, humidity, and desk occupancy. And in addition, advanced IoT submetering was introduced to monitor individual distribution board circuits so that we could isolate underperforming systems and identify the specific offenders responsible for excess energy consumption and emissions. And this system-level intelligence allowed us to specify our retrofit plans based on carbon impact so that we could develop a response that would yield the highest sustainability reward and give us the best return on investment. Now, all of this was based on BIM data. So the geometry that you see in there came from our BIM models, and the information, the asset information that we included in the model all came from BIM, which was the foundation of good information management for this further innovation. The result that came from this was significant energy savings, improved carbon performance, and a scalable model for future sustainability. So informed by those digital twin insights, we took a strategic 3-month retrofit in 2023. So you can see there between June and August 2023, that is when we delivered our retrofit project. And the key interventions of that included the installation of intelligent low energy LED lighting, high efficiency air source heat pumps. There were no horses involved. And an expanded electrical vehicle charging infrastructure to support low carbon commuting for our employees. And these upgrades directly address the inefficiencies that were identified by our monitoring system, by that digital twin. And they also aligned with our wider sustainability and staff wellbeing objectives. So we were able to look at our sustainability objectives, our staff wellbeing objectives, compare them against the data that we were receiving through our model, and then come up with a highly efficient retrofit plan where the retrofit would target very specific areas that would give us the highest return on investment. So let's talk money. So as you can see, post-retrofit, our energy costs immediately dropped. And by 2024, our annual energy costs had gone from almost £40,000 a year to less than £10,000 a year. So as you can see there, the orange data point is when we did the retrofit. So you can see June time, it suddenly takes a significant drop off. And then the following year, which is the green line, it is an incredible amount of savings for our energy outputs. The actual saving was £29,985 per year, which is £2,499 a month. So that's a 24.5% reduction in energy costs. Now, the capital cost of these refurbishment works was £425,000 a year. We couldn't afford that as a small business, but we were tenants in a larger building. So we were able to talk to the building owner and say, look, this will have benefits for you as well. The EPC rating of your building will improve. It will be more profitable. And so the agreement was that they would pay the upfront CapEx costs and we would pay that back through a rentalized agreement, increasing our rent by £2,208 per month to pay off those costs. Now, after all of that, the net saving for us, because we were still paying our energy bills, was £3,485 per annum. So about £290 per month, which doesn't sound like a huge amount, but it is still a saving. But ultimately, money wasn't what we were interested in. The EPC rating for the whole building improved from a D to an A. We had significant Scope 2 and Scope 3 carbon reductions, enhanced indoor air quality and thermal comfort, improved lighting, reliability and sensor automation, and increased employee satisfaction with the working environment and the electric vehicle infrastructure. So more people were coming into the office. We had no complaints about the office environment. People enjoyed being in there, which then led also to social improvements like greater collaboration, a higher sense of teamwork and staff retention. So we also had from this a lower carbon footprint per employee, despite the fact that the company grew between 2022 and 2024. So we had more people, but a much smaller carbon footprint per employee, which then led to us getting externally verified by Positive Planet. So they recognized the improvements that we had made, and we got the accreditation for that. This also formed part of our application to become B Corp accredited, and we are the only multidisciplinary consultancy that we know of that we can see on their list that has this accreditation. So that's all well and good, showing you what we've done at our own office with a very compliant client, which is ourselves. But I also want to talk to you a little bit about what we've done for one of our much larger clients with a much more unique issue. So this is digital twins for education estates. We were approached by a multi-academy trust to help them to digitize their estate. So this is a trust that owns 32 different schools in its portfolio. And they weren't exactly sure what that digitization needed to look like or how it might work, but they were certain that they couldn't carry on how they were. They were hemorrhaging money, it was very unorganized. And after many discussions about their pain points and their existing digital portfolio, we helped them to put together a wish list for digital transformation, and that included centralizing their asset data, removing their reliance on proprietary systems, better facilities management, making it much smarter, enabling retrofit planning aligned with their net zero ambitions, and the solution needed to be accessible to both technical and non-technical users. So because they were using this for facilities management, it needed to be accessible to caretakers, admin staff, head teachers on site, not necessarily the people who procured the system and that understood how it worked from a more detailed perspective. So from this wish list, we designed an open outcomes-led digital twin strategy, and that had long-term scalability in mind. So whatever we built, we wanted to then be able to bolt on and build on more and more in the future as the client became more sophisticated and as the estate grew. So this is how we started. So the first thing we did was a review of their existing assets. What does each individual school already have in place, and what from that can be utilized? Essentially, what can we get for free? Now, this intelligence was spread far and wide. Some of it was known by the trust, but some of it was only known by the facilities management or the on-site maintenance teams in each individual schools. Some schools had a building management system with smart functionality, but others didn't. And for many of the schools, the CAFM system, the facilities management system, was literally just the school caretaker, the admin staff, and a spreadsheet. So there was no consistency in the way that information was stored, organized, or labeled across the estate, and many of their processes were still paper-based. So once we did have a clear understanding of what they had in their existing estate architecture and their needs, we put together a proof of concept across 2 schools. And that involved optimizing the 3D models that they'd got from the NZAP program. Now, NZAP is a program that was put in place to help schools and education establishments build up their digital portfolio, so they could get very cheaply 3D models, BIM models of their assets. Now, because they hadn't specified their requirements before the production of those models, the asset data was not to any of their naming conventions. It wasn't organized in a way that was useful for them, and a lot of the geometry wasn't quite to the level of detail that they needed. So we optimized those models in the first instance, and then we structured the asset data as required for the digital twin solution and as per the Department for Education naming conventions, so that they were in line with the wider Department of Education. We integrated their compliance documentation, surveys, and their O&M, their operation and maintenance manuals into the solution. And all of this was brought into a digital twin environment, and that became the foundation of wider estate insights. So they were able to see from these proof of concept schools across the schools where they were performing well, where they were underperforming, where there were issues, and manage all of their maintenance through this digital twin. So, armed with the outcomes of the existing asset review and the proof of concept, we were then able to put together a set of information requirements for them to ensure that all future works, either new build or retrofit, had a data handover at the end that would be consistent with the requirements of their new digital estate solution. So this all comes back to the very basics and the foundation of BIM. We produced for them an OIR, Organizational Information Requirements, to identify their strategic goals, explain who their key stakeholders were and how to best engage them, and to define their high-level information outcomes. We produced an AIR, Asset Information Requirements, to identify which of their assets needed to be managed, so their maintainable asset list, set out their data fields for handover and ongoing facilities management, and we helped them to prioritize their high-impact systems like HVAC, lighting, renewables, those systems that needed more asset data and a much more rigorous maintenance schedule. And then that in turn led to individual EIRs, Employees Information Requirements, for each retrofit project and each improvements project. So they then were able to specify their data requirements in a very simple way because they'd done all of the legwork with the higher strategic piece. They were able to clarify the formats that they wanted, the standards, the roles and the responsibilities when it came to asset information handover, and also include information on their validation and the delivery methods that they required. So this digital twin delivered smart planned preventative maintenance scheduling, and that was assigned at the asset level rather than portfolio or wider building level, and the SLA, service level agreement tracking, which was connected to their contractor performance. So they could determine whether a contractor was performing in a way that was aligned with their service level agreement. It produced dashboards to monitor energy use and identify carbon reduction opportunities for the client. And all of this was designed to work for both the facilities teams and the leadership. So we had custom views to support accessibility for all of the different role types. So people only saw what they needed to see to do their job properly. Even at this early stage, we're just out of the proof of concept now. We've done a few schools out of the portfolio. We can see very tangible benefits. Risks improved, compliance management is now centralized, maintenance has shifted from reactive to proactive, and the trust can now make informed decisions about where and how to retrofit across their estate. And they're also seeing real operational savings and better staff engagement. So these metrics here were put together by the client themselves in a review of the solution. And the great thing about this is with the estimations that they've put in place here, they will have got the money back for the implementation within 2 years easily, which means everything from there is just pure saving and profit for them. All of the carbon reduction as well is significantly of interest, which all reduces cost and all makes their schools a more enjoyable and safe environment for their students to learn in. So next, we will be scaling the solution across all of their sites. We want to enhance the integrations with existing systems. So we want to pull in information from their finance systems, from their HR systems, so that they can integrate all of that data together and report on it from one centralized point of visibility. Now, this is not pulling everything all into one solution. It's through a series of APIs and integrations. This is just the visualization and the analysis of that data. And we want to further develop the platform to support retrofit procurement and bids and funding for them. And all of this is supported by training and clear asset information requirements, so the platform can remain usable and relevant long term. A big thing that we really push for in this is for the clients to take ownership of their own solutions, to really understand what they've got, why they've got it, and how it works. Our ultimate goal is to empower them to host their own twin without any reliance on proprietary systems or long-term consultants. So essentially, we want to build ourselves out of an ongoing job. The only time that they would need us or any other kind of consultant would be if they needed to make significant changes to the system that they have in place. So that's what we delivered, how we've delivered it, and what the plan is for the future. And also the information about the case study from our own office as well. So hopefully you can see that through the basics of BIM leading into digital twin implementation, you can make significant monetary savings and significant reductions in your carbon. Thank you very much.
Thank you, Vicky. Thank you so much. That was excellent. Let me get it again, my screen, just to call now. Just to let people know, we will answer the questions after the Melanie's presentation, okay? I will now please want to welcome Melanie Robinson, sorry. Melanie, it's a pleasure to have you here with us today. The stage is all yours now. Thank you.
As I say, hi everyone. I work for a company called Okana, and Okana is a consultancy similar to One Creative, in that we pull together a lot of different disciplines and consultants under one roof, really focusing on sustainability and digital, with the tagline "Let's Shape Tomorrow." The values that drive us, that hopefully will come through this presentation, are empathy, curiosity, and excellence. But first, I wanted to go over why better information is, I guess, the tagline to everything that we do. And fundamentally, it comes from that lack of good quality asset information, and absolutely what Vicky was talking about in terms of the education trust and the type of information they were dealing with is testament to that. What we've seen as well is much more interest in wanting to get better information because of things like the climate emergency, because of things like the Grenfell fire disaster here in the UK a few years ago. These are all making us wake up to the fact that information is ultimately going to help us make better decisions and actually understand what's happening to our built assets. The reality is that a lot of existing buildings deal with poor quality existing information. We are getting better in the sense that it's becoming more digital, but a lot of people still rely on paper, on ring binders, on a lot of physical information. But just because it's digital doesn't necessarily mean it's better, and that's because it needs to be structured. So a lot of us, and myself included, I'm definitely not practicing what I preach on a personal level, is how we store our files on our computer. And oftentimes it will be very unstructured in terms of how it's named, even folders are used ad hoc, and ultimately, if we think about how we manage an entire estate, let alone our own personal lives, it is really difficult to find information if it looks something like this. So what we've got to do is flip it on its head and think of information as just as valuable as our physical assets. So just because it's not tangible doesn't mean that it doesn't add value to your portfolio. And in fact, one of my current projects is actually focused on the fact that they're increasing the value of their, or the saleability of their asset, because the information that they hold is up to date and reliable. What this ultimately means is both require life cycle management, in the sense that whilst we have to maintain our physical built assets, we also have to maintain our information assets as well, and think about not only how we're creating that information, but how we're managing it throughout the entire life cycle. And a good testament to that is, if anyone here has worked in a BIM-esque environment in the past, will know that model software is an example of that, where if you don't use your models and upgrade the subscription, you often have issues struggling to access those models, because we've not kept that information up to date. Now, that has its own problems, and we could go into a lot of detail as to why that is problematic in its own right. But ultimately, we need to look at the whole ethos around how information is managed more generally, and the fact that it's not just about models either. A good way to phrase this is, as built information, if we do not maintain it, is only ever as good as it is at the point of handover. And then over time, it will naturally decline, just because it becomes out of date. There are lots of interventions on your buildings, you're extending it, you're changing things out, you're servicing information, you're servicing equipment that needs more information updated on it. And what that ultimately means is, as I say, it declines over time. Whereas if you maintain that information, it will maintain the quality and the value that that information holds, and you can be sure that you can rely on the data that it is feeding back to you, because you know it is up to date, and you know that it reflects the physical conditions of the built asset. So yeah, as I say, we need to think about the entire life cycle of information, and actually that's getting more prevalent as we're thinking about AI, and we're thinking about other sorts of digital interventions. So it's not just about, as I mentioned, the creation and even the management. Actually, it's also how we delete information as well appropriately. So one of the big spotlights at the moment through the use of AI is actually on the amount of power and water that's being used to service the data centers that are facilitating the use of AI and the likes of ChatGPT. Actually, what we need to be thinking of is what is actually obsolete, what can we get rid of, what can we delete ultimately, so that we are maintaining a healthy amount of information and not drowning in it as much as we are holding useful information. And this is why ultimately you should care. And similar to Vicki, we need to go down to monetary benefits in a lot of ways, just to try and make that a lot more tangible for businesses. I can't take credit for this. This was one of my clients a few years ago, and they did an interview of their staff across their estates department, to see how long it was basically taking them to find the information that they needed to rely on to do their jobs. And there were some shocking statistics that came out of that. Up to 334 hours a week were spent searching for particular work documents, which is insanely scary when you start applying as I say, monetary values to that. And they found that it was equivalent of 2 full-time staff spending a week looking for information. Okay, so that's the why. But what does this all mean? So as Tyza wonderfully set out at the start, there is a flip in terms of how we're focusing on what I guess we called building information modeling, to better information management. And that's essentially the what in all of this is the information that sits behind it all. It's because that information is, as I keep mentioning, unstructured. And this report is a good few years old now. And to be fair, I could do with some to look this up to see if this has changed. But at the time, 96% of data generated in large infrastructure projects was not used at all. But more to the point, 90% of that data is unstructured. Now, what does that mean? Well, quite simply, computers are dumb and they need structure. They need clear language. They need apples to be called apples, but not just apples to be called apples, apples to be called apples in the same consistent form throughout. Because whilst we as humans look at these 3 apples on screen and go, yep, that's the same thing, they're all 3 apples, a computer will read them as 3 different things simply because of how they are framed. Why am I telling you this? Well, if we take our humble boiler, house boiler, and we have 3 different pieces of software that use that boiler or reference that boiler in some way or another. Again, thinking back to one of those examples that Vicki showed in her presentation, if they're called different things, computers will absolutely assume that they are talking about 3 different things. So when you're trying to correlate all this information and understand relationships between different data sources, it's really difficult to do that because it's quite simply referred to as different things between different tools. This is important because this forms the foundation to better decision making ultimately. And I've borrowed this diagram and built on it in a lot of ways, because ultimately absolutely everything we do begins with that data. And what we found over time is that a lot of clients actually don't even start with that. They start with missing data. They start with completely differing formats, maybe data that's not even suitable for their needs. So we need to work through with them to look at, well, how do we make that better data? And again, Vicki, what Vicki was going over speaks to that quite in quite a lot of detail, in the sense of like, what is it that you can use that you've already got access to, right? How do we improve that? And how do we start building meaning into that so we can draw some wonderful insights, understand relationships between different actions, ultimately drawing insight and then intelligence, in the sense that if we manipulate something else changes. That's when we start becoming truly a digital twin. And ultimately, an early version of all of this is BIM for facilities management. And this is how I kind of visualize it in a lot of ways, is that we feed a lot of different data silos with a lot of different types of information, that we need to be able to pull it all together. And you could use like an integrated platform, you could use a digital twin platform, you could use anything like that. But again, it needs to rely on that standardized happy data for it all to speak nicely to each other, so that it knows what it's referring to, in the sense that that's boiler 1 over there. Boiler 1 has XYZ data attached to it, and it's based in that room over there. It seems quite simple, but this is what all makes it tick. Okay, cool. Well, what about how? Well, the how actually needs to be driven by what you want to achieve out of your digital information. Digital information is as long as a piece of string. It can be really, really basic, and that can be absolutely fine if that's what you need it for. Or it can be really, really complex, in the sense that it helps you control certain parts of your building. And that's a spectrum. That's a journey in terms of where you need to get to. So one of the things that we do with our clients is help them understand, well, what is it you need for what scale you need it for, and what then is the best intervention and solution we can support you with. And a lot of times they don't need anything too clever, because what they need is something that they keep up to date digitally in the background to just reflect that as maintained condition, so that their information stays reliable, and then they can start building in more intelligence. So a lot of people need to, get this bit right before starting to move to that intelligence. So this is what that BIM word was trying to do all those years ago, and again, BIM for FM, before we start really getting into the nitty gritty of digital twin. And again, it comes back to why we want to use that information. So what we've tried to do is map on, I guess, high level use cases against that spectrum, to go, well, is it a case of you want to be able to monitor how your building is performing, or do you want to be a little more forward thinking, a little bit more diagnostic about what your building is doing? And then that will help define what level of information you need to essentially invest in, because you know, we're not going to be shy about this. A lot of this involves a lot of investment. It does involve not just money, but also time. It needs culture change. It needs the people buy-in. It needs training. It is a significant journey. So plotting that out in a way that means that you're able to demonstrate that you are doing it because it is good for your outcomes, your business outcomes, and for your organization is really critical. I won't go too far into digital twins. Vicki covered that really quite well. But ultimately, it comes back to looking at the purpose of why you need information. Have you got that information in the first place? And then how we can create better information over time with a view of creating more intelligence. The purpose then drives what type of data you require, which then in turn influences the capabilities that your organization needs. And the last bit of the entire puzzle is, of course, your technology, but it's just that. It's the last piece of the puzzle. It's very much we've got the groundwork in place, which technology is best suited for our needs, and making sure that, you know, we still have ownership over our data, that it is what we need, not what the software vendor wants to sell us. And just to put that in, because we all love a good meme, just to put that in relatable terms, one of our case studies that we've got that we can't speak too much about was a manufacturer. And whilst their design and construction requirements were extremely detailed and wonderful, and they were creating wonderfully rich digital models for the purposes of design and construction, as soon as it came to FM, it fell by the wayside because they weren't able to use that information. They didn't really understand it. It wasn't really integrated with any of their other system, and it sat in the equivalent of a dusty cupboard in a digital space. So the two worlds were completely disjointed because they hadn't done that overarching why, that real fundamental deep dive into what they need. And one of my other favorite examples is the Humble Watch. So to keep it really simple, so I can quickly jump on the case studies with the last 5 minutes, is sometimes you just need to be able to tell the time, maybe set a timer. Do you need to invest the 500 odd €euros for a really intelligent smartwatch that goes into your oxygen rate and all sorts of clever data, if that's not what you need it for? I mean, sure, it looks good, but it doesn't necessarily meet what you need it to do. So you need to be really, you really need to interrogate whether you're going to use that and whether you're going to get the value for the money that you're going to spend. Cool. Well, we all like some case studies, so I'm just going to go through a few that hopefully give you a bit of a flavor of where we've pushed for better information and what impact that's had through that deep dive into does it meet your organizational needs, and then what that means for them moving forward. So the first one, we've spoken about this one for about 10 years because it is such a good example of what is actually really quite an early example of what we would call a digital twin, is the Sydney Opera House. Very recognizable landmark. And what's really powerful about the Sydney Opera House is that it is very much about heritage buildings as it is about new buildings. So the client ultimately had, if you can imagine, over 60, 70 years, a lot of different data sources, a lot of different data, a lot of information that resided in spreadsheets and paper and all sorts. What they wanted was to be able to see it in one single source and be able to make better decisions off of that. So what we did was we undertook some really detailed consultations. We got to spend some time out in Sydney, and we got to map all of that out to try and understand what they needed from a technological solution. And the map ultimately looked something like this, where it had lots of different reliant systems. It was very disparate. There were some completely siloed systems. So what they did was they commissioned a 3D survey of the Sydney Opera House and wanted to use that as the single window, if you will, that pulls all of these different systems in, and you can use that 3D model in order to interact with that information. They also developed what we called a check-in, check-out system so that you could portion off bits of the model so that you could look at different pieces of information at different times, and also feed that to different contractors without having access to the wider information. The results were we got a really intelligent model fundamentally, but it was very much the client drove the technical specification. And what that meant was even to this day, the Sydney Opera House still relies on that model and the information that sits behind that model to operate their building, because it was something that was built with their organizational culture at the forefront of their minds. I won't play the video just because I've not got time, but I'll just show you one more case study and then open the floor to questions. The other one, this was actually the first project I ever worked on when I joined Okana almost 6 years ago. And this was a gold and copper mine in Greece. Mining is a really interesting part of the, if you could call it, part of the built environment, because it not only has buildings, it also has pits, it also has conveyors, it's got roads, it's got vehicles, it's got fixed assets, it's got movable assets, it's got caves even. It was a really complex site. So what the client wanted was, we want to apply some form of BIM to this, and bear in mind that a lot of the way they managed that information was via books and clipboards going around on site, marking it up with pen and paper. So there was a real opportunity to have a look at, again, what those data requirements were, what was missing, and how we can bridge that gap and create an intelligent view of the site. So what we did, we, again, similar to the Sydney Opera House, undertook a very deep piece of research with them to understand where their heads were at, where they wanted to go, and what they wanted to achieve out of a digital information management approach. And the other thing that they wanted to do, and this was something unique to us at the time, was they wanted to test their requirements, because they didn't want to go out and procure a piece of technology that wasn't going to be fit for what they needed, because they weren't entirely sure what they needed. So we built a piece of technology, and I will play this video in the background. What they did was we developed a piece of software in-house that created mocked data to show how the model could be interacted with imaginary IoT sensors in there as well, and linked to an imaginary document management system. What this also did was actually show how over-detailed models aren't necessarily the right thing. So it was a third party that had created this particular model, and it's got crushers and grinders in there, but they had gone down to the details of every nut and bolt. So there's a significant lag in how we interact with this model. And it's because, and you can see through the still work there, that there is a lot of information embedded in this model. But yeah, what this allowed them to do was really test those requirements and really get an understanding of what they needed before they went out to market to procure a software based on the specification that they ended up writing, which then relied on a very comprehensive set of information that was structured to a unique schema, because it was such a complex site for a mine. So I'm just going to stop there to allow for questions, but thank you for listening. I hope that was useful, and I hope it was complementary to all the work that Vicki has been doing as well.
Thank you, Melanie, for those excellent insights. Thank you. Let's now move to the Q&A session. We have a lot of questions here in the chat, so I will start, okay? So I will start with you, Vicki. What is the name of the digital twin platform that is used at one creative environment? And I will merge with another one. Your company work in Dubai?
We can work in Dubai. We haven't yet. So we have worked globally with lots of different clients, and we're in talks at the moment with a company in Dubai, but we haven't actually delivered there. But when it comes to the platform itself, we don't have a single platform that we use. We have a series of partners. So in the two examples that I showed, the first one with our office, that was actually ACC. So Autodesk Construction Cloud with a series of different integrations, elements of Mobius Flow, and support from a company called BIMify as well, who have a software, an AI software for the development of BIM models. And then for the education estate, it was TwinView, supported by Grid Edge, and then there were another, oh gosh, 4 or 5 different platforms in there as well. So it really is, we're not tied to one solution. We're the builder and the configurator. So we do have a software developer in-house as well, but we also have an integrations expert, and it's all about creating the visualization and the ecosystem that is right to solve the problem that we've identified.
Perfect. Thank you, Vicky. I will do one question now for you, Melanie. I would ask you, what are the biggest challenges organizations face when trying to keep their information accurate and reliable?
So the biggest challenge that we've faced is kind of not understanding where to begin. Fundamentally, it's again, that's why I emphasize so much about understanding the why that sits behind it, because oftentimes people don't actually have that intrinsic view of what they're wanting, and it can be a little bit like, well, yeah, where on earth do you begin, which makes people then not want to do it. I think the biggest piece of advice I would give is basically structure a comprehensive audit of A, what you want, and then B, what do you have. And again, I think that Vicky spoke to that really quite nicely with the education example, with what is that free resource that you essentially have because you've already got it embedded in your operations. And let's start there. Is it fit for purpose based on that audit of your objective needs?
Perfect, Melanie. Thank you so much. I would like to do now a question for both of you. That's Vicky and Melanie. Why the growing need for data centers, gigafactories, SMR, and AMR, nuclear? What are the hindrances or potential risks of information management and digital twins? As an example, potential security risks.
The risks to delivery, I guess, are things like being penned into proprietary systems. So we see that quite a lot, where a solution has been provided by a software provider, and then that solution becomes more expensive, or it doesn't innovate as much as some of the competitors, but ultimately you're trapped into that solution and that environment. That's a big risk when implementing any kind of innovation like this. In terms of information security, that's huge. It always should be something that is questioned and considered. So, for instance, one of the conversations that we always have when we're looking at clients and the assets that they've got for free is also, can we see all of the contracts that you have with all of your vendors? So that we can see any clauses around information ownership, information storage, and if they're not covered in the contract, we want to be able to deal with that supplier on your behalf and raise those questions with them. Now, physical storage, in my opinion, is always slightly more risky than cloud-based storage. Ultimately, if you're using something like Azure, there are so many different sort of ways to prevent breaches and downtime, so many different like gates to have to cross, that if an environment in Azure has gone completely down, chances are that you're not the only one affected. You know, Microsoft will be down completely, you know, all your Office systems. There are so many different systems that are hosted on something like that, that the least of your issues would probably be the fact that you can access your digital twin. APIs and any kind of integration are always a weak point in that area as well. So I would suggest that regular pen testing is an absolute must, at least annually, probably biannually. I don't know, Mel, if you'd add anything else to that.
Yeah, just to add with I think there's more of a need these days for us all to be upskilled in cybersecurity. And I'm not saying down to be us all being experts, but just being aware of what could potentially happen, because a lot of information to do with the built environment is actually really quite sensitive if you think about if it gets into the wrong hands in terms of what could potentially go wrong. So I think there's elements of that we should probably consider, and any good strategy looking at your digital twin ecosystem would have that baked in the sense of what are the protections there, what are the contractual liabilities as well, and what data is considered sensitive compared to what can be shared wider as well. We've got to be really careful when we talk about opening up, national level digital twins and what that actually means in reality, because what it actually means is a layer that we are absolutely fine to see, but a lot of the detail behind the workings will need to be a lot more locked down, for lack of a better term.
I think there's just to add to that as well, one of the biggest risks is internal, and a lot of organizations overlook that. So especially things like access privileges, being able to remove someone very quickly from a project, especially if they're dismissed or if there's any kind of ill feeling with an internal employee. And that is one area that isn't considered enough. Also, the access levels in terms of people only seeing specifically what they need to see. And I saw another question there about where we work at One Creative in terms of is it kind of single entity clients, is it estates, is it cities, and that's why we focus on estates, because it's big enough to make a massive impact for a client that could be struggling and has a big need, but it's not so big that we fall into this realm of complete uncertainty. I think smart cities and the elements behind that are very interesting. I don't know if I would personally want to tackle that at the moment with all of the unknowns that are there.
And all of the stakeholders.
And all of the stakeholders, yeah.
That's great, girls. So that concludes the Tracker 1. I would like to invite everyone that still have questions or doubts to connect with Vicki and Melanie. Reach out then on LinkedIn or send us your questions and we will address them. So on behalf of ZIGURAT, I want to thank you, Vicki and Melanie, for sharing your expertise today with us, and all of you for joining and engaging with us today. Do you want to leave a message, Vicki and Melanie, really quickly, because we are running out of time?
Yeah, I can. Yeah, no, thank you all for listening in. And just to echo Tyzer's point, please feel free to drop us a line. We're always happy to talk about digital twins, BIM, information, data, you name it. Yeah, happy to chat.
Yeah, I'll drop my LinkedIn in the chat, so feel free to add me.
Great, Vicki. Thank you. So we also thank you to our sponsors, Ecotech and BIM Community, and as well as our institutional partners, CIAT, CIOB, Smart City Council, NEMA, and BIM Corner. Stay connected. Tracker 2 will begin in just a few minutes, okay? Thank you. See you soon. Thank you so much, Vicki and Melanie. James and Andrew, see you soon, okay? We will start in 3 minutes. So hello again, and welcome to Tracker 2 of the ConstruWeek 2025, the annual ZIGURAT event dedicated to BIM. For those join us now, my name is Thaisa Figueroa. I'm an architect, program owner, and institutional relations at ZIGURAT, and I will be moderating this session. This tracker brings the discussion into the field of complex infrastructure projects, exploring how we can integrate and manage large-scale data efficiently, adding strategic value across the full life cycle of infrastructure assets. That's the essence of this year's theme, Beyond BIM, Better Information Management. A quickly reminder of who we are. ZIGURAT is a leader in online practice-based education for the AEC professionals. We provide programs designed to connect cutting-edge theory with real-world application. Our base is in Barcelona, but our community is global. We have more than 20,000 alumni from more than 120 countries, and our faculty is international and active in the industry leadership roles. Let me pass. This session is related to the Masters in Global BIM Management in Civil Engineering and GIS. It's a 1-year, 100 online program that prepares professionals to manage complex infrastructure projects using BIM, GIS, and emerging technologies. The next intake will begin in November 2025. So to learn more, feel free to scan the QR code or check the link that we will share on the chat, okay? Now, let's begin with today's presentation. HS2 Digital Engineering Journey, Building the Future of Rail. And we are honored to welcome James Daniel, who is Head of Digital Engineering at the HS2 Limited, the company responsible for delivering the UK's new high-speed railway, where he leads digital strategy and innovation in engineering and construction. And he's also the director of our Masters in Global BIM Management in Civil Engineering and GIS at ZIGURAT. And we have also here Andrew Robinson, who is a consultant at Bentley Systems, a global leader in software solutions for the design, construction, and operations of infrastructure. ZIGURAT, as an authorized training partner of Bentley, proudly integrates Bentley's digital solutions into our Masters in BIM Management, supporting the development of the next generation of industry professionals. James and Andrew, it's a privilege to have you here with us. Thank you so much. A quick reminder to our audience, feel free to send your questions on the chat. We will address them at the end of the session, okay? And now I would like to pass you the floor. James and Andrew, welcome. Thank you so much. And the floor is all yours.
Thank you, Teza. And thank you to Vicki and Melanie, who did track 1 just before this session. If you get a chance to watch it back, please do. It's really informative and really great to see some great questions come through from some of my own former students on my course. Thank you very much for attending and being part of that. And I hope you asked some great questions here too, as Andy and myself take you on a bit of a journey of what we've been doing here at High Speed 2. Just as an introduction, my name's James Daniel. I'm the Head of Digital Engineering here at High Speed 2. I'm also, as Taser said, the Masters Director for our BIM and GIS Civil Engineering program here at ZIGURAT, and the first program to receive a CIB accreditation in Spain, which I'm really proud of. I'm really proud of my team and the people at ZIGURAT to help achieve that. And hopefully, with what you're seeing here today, that will go some way to explain some of the things that we try and tackle within the ZIGURAT family, but also in the wider industry with the challenges that both myself and Andy have to address on a daily basis. I'm James. Andy, did you want to do a quick introduction to yourself?
Excellent, thank you, Jane. So I'm Andy Robinson. So I'm the program director from the Bentley, who are the strategic technical partner to HS2, and I've had the privilege of working with James over the past few years to make all of this stuff real. Back to you, James.
Thank you. So Andy and I are going to do a joint presentation today. Andy's better at driving these things than I am, because I tend to get carried away with talking. So he will keep me to task and keep me to time, as I'm sure Tayser will as well. So I'm going to just set the scene of who we are, what we do as an organisation, and some of the challenges that we have within my team, and how we can support the wider project. And as we go through the slides, the presentation, you'll get to see some of the tools and processes that we are using within our team and our project. So as introduced, we are delivering Britain's newest high-speed rail, HS2. For those of you not based in the UK or parts of Europe, it's quite a large infrastructure project. I'd go so far as to calling it a mega project. It's probably the largest mega project we've had, certainly in the UK, for nearly 100 years, and most excitingly across Europe when it comes to transportation infrastructure. And I'm sure on the screen you can see some of those statistics there. So it's a 140-mile long rail project. It's the first to be built north of London in over a century, and the ultimate task is to provide faster, more efficient journeys from central London to obviously Birmingham, where the track concludes, but to give people more opportunity to continue their journeys more into the Midlands and the north part of the country. You know, we've got 4 new stations that we're building along the route, 65 miles of tunnel. And these are big tunnels. You know, we've got viaducts, some of the first viaducts that have been built since the Victorian times. And if you're near a computer, which you obviously are because you're watching us today, do take some time after the presentation to go onto YouTube and look for the HS2 channel and have a look at some of the sheer impressive feats of engineering we have with things like our Colne Valley Viaduct project just north of London. An absolutely amazing piece of engineering, and there'll be some examples of that later on when Andy delivers some of his slides. And most of the rail is actually going to be hidden from view from the sheer size and scale of it. The engineering and design challenges are very much trying to minimize the impact of the environment in terms of the aesthetics and the visibility and the environments in which we work through or drive through. Most of that will be hidden from the public view so as to not disturb the countryside in which we will operate in. And of course, to deliver all of this, we have to handle huge amounts of data and information, so much so that it makes my head sort of pop, really. And sort of just understand that at this point, we're managing over 2 million assets in terms of digital information assets, whether it's CAD, GIS, flat 2D information from a digital perspective. But of course, in the wider context, we've got millions and millions of data sets when it comes to documents and information. From my perspective within my own team, I look after the digital engineering, as I've already alluded to, but my team's made up of 80 people. And within those 80 people, I look after document control, who are all embedded across the different aspects of the project, handling data on a daily basis using document control and common data environments, which we'll allude to later. I've got CAD, GIS, and asset management teams who are looking at cradle to grave elements in terms of what's being designed, what's been approved, and what's been constructed in order to create digital assets, digital repositories, and asset management or asset maintenance opportunities as we go into operating the rail when it comes into service later on in the next few years. And of course, we have our strategy and implementation teams where we're going out and supporting various stakeholders across the project who come up with ideas or look for problems or identify problems where we can try and manage and mitigate those risks and put them into play to try and take out any unburdened costs or issues, both within the project and obviously to the wider stakeholder and through to the public. So it's a big project. We've got 30,000 people in our supply chain, and potentially growing because we're bringing on board our rail systems contracts. 3,500 businesses in our supply chain, and everything, and more than half are small to medium enterprises. So small businesses, not just the big mega international companies. These are people that are local to our project, local to our nation, and a lot of people that we're proud to work with and support. And it really is helping support the growth of our economy. And that will continue over the next 10 years as we start bringing on board our rail systems contracts. Again, we'll get into that later on. So just as a brief timeline in terms of the history of HS2 to date, 2009 was when the project was conceived and created. 2012, the DFT, the Department for Transport here in the UK, confirmed the project, and then the high-speed rail bill was passed in Parliament, and then it was the hybrid bill was passed in 2016, or just as we hit 2016. And as we sort of go towards 2017 and 18, this is when our main work civils contracts. So if any of you have seen HS2 or High Speed 2 online in the media, in the press, or you've worked on it, that the main work civils contracts is basically the big heavy civil engineering works that you see on screen, where we're creating stations, we're creating cuttings in the countryside to put, you know, the track and the rail and the power cables down, etc. Really big, heavy stuff, really complex and complicated stuff to make sure everything works together. And there are 4 main work civils contracts made up of anything between 3 and 4 tier 1 contracting partners. So when we talk about the size and the scale of the project, it's massive in simple terms. And as we move through to 2020, 2021, our stations contracts have been awarded and work has started on those already. And if you're in the sort of the Birmingham Midlands area, you'll see some very clear evidence of those stations being constructed in urban Birmingham, which is actually fantastic to have a look at. And in 2024, so the end of 24-25, as we are now, our rail systems contracts were awarded. And the rail systems contracts are ultimately how we're going to operate the trains and the power and the lighting and so on the tracks that we've created along the route. So no chance of project slowing down. We are right in the middle of the tornado of HS2 at the moment, and it's a fantastic place to be. And of course, with any project, if we can go to the next slide, there we are. We have obvious challenges that we face, whether it's a mega project, a major project, or even a small construction project. You know, we talk about cost, we talk about time and regulations, we talk about, you know, funding, how things are going to talk to each other. And in the previous presentation, Melanie and Vicki talked about the integration of different tools, how they're going to talk to each other. And that's no different here in my world in terms of infrastructure and big mega projects. One of the challenges we have is obviously how do we get that to then come together at the end and operate and maintain and have people actually use the asset, the railway that we're building. And for this particular presentation, we're going to focus on just 4 areas of concern, which we see on a daily basis within major projects. That's obviously things like cost and time. You know, how do we understand where the money comes from, where the money goes, how much things are going to cost, what the value of those things are going to be delivering, and so on. How do our tools talk to each other? How does all that information that's coming in at a rapid rate of knots be utilized, be exploited, be integrated in different platforms, give people the right information at the right time, provide a singular source of truth, if you will? How does that all work or function in order to give our operations and maintenance teams a chance to know how to operate the railway, how to maintain the railway, whether it's day-to-day operations or whether it's for security or for anything else? And then, of course, we have to look at, you know, the capacity in terms of we've got 30,000 people in our supply chain. You know, we're going to be absorbing a lot of professionals within our environment that are going to potentially impact other construction-related projects in the regions that we operate or in the specialisms that we have. How do we make sure that our workforce is properly supported, upskilled, and give them the longevity in their career to make sure that what they do here benefits other projects that they work on in the future? So as we sort of move towards that sort of goal of what do we need to do, we have to understand our purpose, both as an organization and also as, you know, within a team. So digital engineering, what our vision is to develop and deliver those plans and how we measure that progress and then refine it in terms of benefits capture and do a loop cycle back to the beginning as continuous improvement. So in terms of purpose, you know, we have to understand what our vision is, what our purpose is. And I'm going to read from some notes that I've got here on the side. So from my perspective within digital engineering, it's about having an efficient and safe decision-making process to make sure that we can support our supply chain and our people in better decision-making processes to increase their role and value across the organization. What's our purpose? Well, our purpose as digital engineering is to act as change enablers, you know, unlocking the value of digital transformation and understand how we can make best for program decisions based on fit for purpose information. And that's a fairly common sense approach, but when you start to scale it up in big project environments, it becomes quite difficult to navigate that narrative through a sea of information. So it's very clear that we have to maintain that purpose throughout the course of our project delivery. And of course, our mission is to make sure that we deliver clear and simple value and benefits. You know, we have to work collaboratively, and that's a message that is clear and abundant across the digital engineering and BIM community in the industry. It's no different here. We just have a lot more people, a lot more moving parts in some respect. We need to understand what our agreed processes are so we can monitor and maintain and improve where that needs to be tackled. And of course, on screen here, we've got things like our vision documents, or strategies, if you will. So things like digital twins, digital engineering strategies, implementation strategies. They're all things that we want to deliver as an organization or as a team within the organization to support both our internal stakeholders and our supply chain. And of course, in order to do that, we have to have relationships with companies like Bentley to understand how to deliver those platforms and those tools and those information requirements through singular platforms or agreed processes where everybody can get to the right information at the right time and have confidence in that information to make sure that what we are delivering isn't going to go awry. And with that, I think it's a fairly good point to move across to, I think, Andy, are you on the next slide, or is it me?
It's me. I'm on the next one. So it'll probably come as a bit as a surprise that someone from a technology organization starting to say it's not all about the technology. The technology is actually part of the story. What we've actually found, having worked with the clients like HS2 and so many other large clients, but also small clients, is to understand what it is that people do, what is the process, what actually sits behind that, understand how people interact, what are the skills, what are the capabilities that are actually required in order to enact that process, the ways of working, which are then linked to the data that's actually needed in order to fulfill the purpose of that particular process, which is enabled by that technology. We found that if this is working in harmony and focused very much on the purpose, why we're doing it, the whole thing works very nicely. If there's an over-reliance on the technology without understanding the process, without understanding the human factors and making sure you have the data right, generally there is disappointment, which nobody wishes to have. I'll hand back to James now to pick up on the civil works.
Thank you. I think, that image it's no surprise to anyone in this field, is it? I mean, and my students of my course see a version of that slide every time we deliver those opening lectures, and it's so important. In order to understand what the lessons are, what the capabilities are, we need to bring forward in our phases of projects, and of course within HS2, obviously we've got the civil works and the stations piece where we've got to make sure our systems are large enough, robust enough to make sure the information coming in is accessible and stored. We're going to make sure our validation processes can be automated where possible, visualize multiple data sets where we can in order to bring in different stakeholders, different supply chain members to see the same information at the same time. And also the sheer volume of information that needs to be accessed by different people. What we'll show you in a moment is some of the tools that we've built with our team at Bentley to help different people from different disciplines understand how to get the best out of the information being shared across the different levels of the project. And of course, for me, it's about minimizing headaches. It's about minimizing rework and cost wherever we can within our delivery mechanisms. So if I can use tools, I will. And they sometimes don't have to be super fancy or super sharp. It could just be a better way of accessing a data set from within a simple environment. But when you scale it into a big project environment, it becomes quite complex. So from this perspective, it's really important to make sure that we understand what our requirements are in terms of our organization requirements, but also from our sort of digital requirements, if you will, in terms of what we expect and when from our supply chain. So it's very clear that we set those requirements out at the beginning and then start to build upon that capability as we go through the different projects, because they will have different timelines that we have to manage too. Andrew.
Thank you. And one of the ways in which we define these requirements is using an IDS, an information to delivery specification, which is underpinning the information requirements that we have to allow us to transact the model data in particular using IFCs, which we're actually using for all of the object types across the project. Now, all the programs that we are involved with, and the supply chain that we're actually working with, and the rest of the digital ecosystem that we have, are all using IFCs in order to actually transact between the different systems and also the the software. And then we're actually using the IDS tools, or some open source tools that we're using as well, which are there to verify the quality of the information which is provided, the actual design of the information that's included within it, but also the relationship between the different classes. And this has been used to great effect now on the civil works part of the contracts, and it's even stronger as we go into the rail systems that we'll be talking to in a few minutes. So these requirements and transactions we're actually managing within an ecosystem which looks a bit like this. Within the supply chain, ostensibly there are two data classes that we're using, or two data types that we're using. There are the documents, and also the model data. And all this information is coming from that complex supply chain that James spoke about. That information is then shared to High-Speed 2, to their connected data environment, which consists of ALIM, or AssetWise, or EB, if you've been around for a while, which is looking after the receipt of the documents, the definition of the information delivery plans, and also managing the assurance, the configuration management, the RFIs, the TQs, the distribution matrices, and so on and so forth. And the model data is coming into ProjectWise, and using the connectors that we have between those two systems, we're able to manage all of those business processes. As James mentioned, the sheer volume of the data that we're dealing with and the number of people that are interacting on a project like High-Speed 2 is non-trivial, and it's really important that we actually have real clarity in terms of the ways of working, the security models that are set up, so that only the people that should see a particular document or have access to part of a model have access to that. And that is possible to set up and scale for a project like High-Speed 2. Having got that data into our connected common data environment, we're then connecting it through to another product, which is called VisHub, the Visualization Hub. And this is the first iteration that we had, which is then bringing the model data, the document data, and augmenting it with a whole load of other data sources, such as project controls, the asset registry, so GIS data, and so on and so forth, and actually making what is quite complex engineering data even more accessible and consumable through a single trusted window into all of that data. Over to you, James.
Thank you. So there's a lot of stuff going on in that picture, which we don't necessarily it doesn't really show how complicated it is, but a lot of lessons learned from my main work, civils contracts, in order to embed our rail systems contracts and set up in a much more efficient and digitally defined manner. So we've got more specific data requirements from that diagram that you saw previously in terms of how we receive, interrogate, manage, and review data within the organization. In our rail systems world, we've understood more so what's required, what formats work, what formats don't, how they relate to each data type, how they talk to each other, or in some cases don't talk to each other, and specifically understanding how we can be more involved with different disciplines within a project like ours and others, such as project controls and maintenance and operations, where we can start to understand what their needs are and how we can facilitate that through the beginning of the project rather than midway or at the end. It's a well-used phrase to start with the end in mind that gets used a lot. And in this case, we did with the first part of the project, and we learned a heck of a lot, because a lot of things we just weren't necessarily aware of due to the size and scale of the project. And what we have done is very proactively taken a lot of lessons learned from that process to really embed that into rail systems. And some of the slides you'll see next really show how we've addressed that and really taken that on board as a really strong way of just going, do you know what, we can do it better, we can evolve, and we can bring more structured data, more structured tool sets, and more robust digital tools into our ecosystem to really deliver confidence in the project that we're working on. So from that perspective, we've really set up some really powerful tools internally that allow us to really help our project deliver much more confident outputs.
This is you as well,
James. Is that me? I'm doing the next one, aren't I? Sorry, I'm out of sync with my own slides, Andrew. I was on a roll there, and I've just completely thrown myself. So yeah, rail systems. I mean, crikey, that picture alone is actually quite a complicated way to describe rail systems. I mean, if you take away the tunnels, take away the vent shaft on the right there, and the landscaping, everything else is rail systems. The track, the power cables, the lighting, the HV, all the stuff that isn't heavy civil engineering is very, very, I call it, it's like the finesse of a project. It's very delicate and very, very, very specialized. And it's very, very important to make sure that we get all of those components set up in the right way at the right time. And to add to that layer of complexity, it's not just one person doing it. We've got at least 12 contracts, if not more, coming into the same space at the same time to do their piece of the work to make sure that this railway is designed correctly, built correctly, and operates correctly as intended. And they're not small organizations. They're really, really big tier one organizations, which I won't mention here, but please go and have a look at our website to see who we are working with, because I know I'll get one wrong if I don't say all the names at the same time. But you're going to know them, and some of you on this call may even work for them. They're not small concerns. And of course, by bringing those organizations in, we need to make sure that everybody's got the right access and the right layer of confidence in terms of what they're looking at. We have an alliance where we're bringing together a group of the contractors to understand how to facilitate collaboration and coordination safely and efficiently to make sure that those complex systems are on time and on budget so we can operate correctly. There's a lot of moving parts here, which is why we have such a large team within the organization, but they are ones that are helping us deliver the success of the railway. So, Andrew,
thank you, James.
Your slide now.
Thank you. So as James was mentioning, the sheer complexity of High Speed 2 with the civils, the contracts has got even greater as we bring in the rail systems as well. There are 9 contracts within the Rail Systems Alliance, and then there are 3 contracts for the supply of some material. If this was done in a traditional way, because each one of those contracts or work packages is reliant on another work package, or in many cases on many other work packages, the actual complexity to coordinate across all of those contracts and disciplines would be absolutely huge. And when you consider the time pressures and the cost pressures that High Speed 2 are under, the need to have really, really clear communication and effective communication is essential. And then if you consider that each one of those disciplines is then communicating with High Speed 2 in themselves, then the whole thing could almost be overwhelming. And that complexity is further expanded when you look at the different data types that are in consideration. So traditionally, we think just about the engineering data, as I mentioned, the model data, the design data, but that's no longer the case. We have subsurface data, we have the geospatial data, we have that traditional design and engineering data. That is augmented with the IoT data, which is measuring the ground settlements and other key factors. We have the reality data that's captured by drones. And then on top of that, we have all of the enterprise data, which we all need to bring together. And that in itself increases the complexity even further. So High Speed 2 decided to use our Bentley Infrastructure Cloud and our iTwin platform to enable this. Why was that decision made? Because it allows us to have the underlying platform, which is now powered by Cesium, which allows us to handle data volumes of the size that we are talking about, and also the complexity and the relationships. provide the interface to that using the Bentley Infrastructure Cloud, which is a way that we use to collaborate and to connect the data and people throughout the whole life cycle, and then using the engineering tools to the left-hand side. So these are our open applications, such as Open Rail, Open Road, Open Buildings, as well as the subsurface. I have some tools that we're using coming from the Sequent companies. So tools like Open Ground, many people will be familiar with, or Plaxis or Leapfrog. And then all of that, we are then connecting through to the it's like asset-wise and asset management side. And all of this is powered by iTwin. And what that allows us to do, because of that contract ring, bringing all of the supply chains together, we're able to stand up our rail system CDE, which is so project-wise, so powered by Infrastructure Cloud Portal and iTwin. Each one of those separate disciplines and contracts are actually connected to and working with that common data environment. That common data environment is there where is then augmented further with another tool called Collaboration Hub. And Collaboration Hub is where we interface, run our integrated design reviews, integrated design checks, do all the clash detection, issue management, etc., all the mechanics of actually delivering a project of this size, which is used across all of those different disciplines, and then is so transmitting that data to High-Speed 2 for acceptance, and then all of that data is then visualized and democratized again using the next iteration of VisHub, the visualization hub, which again is bringing the civils data, the rail systems data, program control data, asset data, health and safety data, etc., all together. Over to you, James.
It's worth just highlighting on that previous slide, actually, what doesn't necessarily come across is the rail system CDE is unique in this industry, as it's a common data environment whereby all of my supply chain that you can see on screen are working in one common data environment. All geometry, all geospatial information is hosted in my common data environment as a client organization, as opposed to 7, 8, 9, 10 independent common data environments where you've got different opportunities to have fail safes or failovers or information not coming through at the right time. What we've created from our lessons learned from the previous project, part of the project, I should say, is having our supply chain work in one space, a particular area of design, will help mitigate risk and rule out any unnecessary problems within that space, which is almost unheard of in the industry as a whole. And I have to take my hats off to my team and my colleagues at Bentley for helping make this possible, because this has been by no means a small task in order to have these large organizations with their own IP and their own approach to digitally delivering designs work in a space that is operated and owned by the client. So that is a really big seismic shift in how we're delivering mega projects. I don't think there's any other project, and as you can tell me otherwise, Andrew, that's doing it in this particular way or this particular space at this point in time. So there's a really big progression there in terms of how to deliver a project with complex and multi-layered organizations. Sorry, I just had to put that in there because I know it's such a big body of work that we don't necessarily go into that in that level of detail.
Yeah, and could I just add one word? So managing that, the complexity, and having the security wrapper around it, so respecting individual IPs and managing the ISO 19650 process that they have to go through when stuff is shared, who has access to it, etc. All of that has been built into this as a common data environment that James mentioned. Thank you.
Indeed. Now, how do we educate people and tell people about this? You know, there's a large amount of information we've just given you, and it's only been a couple of 40 minutes. We employ a lot of people within our supply chain. We employ quite a lot of people within our organization. Excuse me, we have a lot of disciplines within our organization that will touch, own, and operate our digital tools that we've put in place. And to that end, we own and operate a website called BIM Upskilling. Trying to take away from our ZIGURAT family here, but we have our own educational portal where we can bring our supply chain members of our team. If you're on the call here, please feel free to go and have a look at it. You can sign up and go through various courses and sub-courses yourself to help understand what BIM means to HS2, or digital engineering, I should say, what the tools are that we use, how we use them, what they mean to us as an organization and our supply chain. And it helps bring a singular message across our entire supply chain in terms of how we deliver the project digitally and what our intentions are. By doing that at the front end with our supply chain and our partners, means that the language becomes less of an issue, the understanding becomes less of an issue, and we can come together on a unified approach to understand what digital requirements are within our project that we operate and deliver. So please do check that out if you get a chance.
Thank you, James. So we have a few videos which we'd like to show you. So we've talked about the complexity, we've talked about the theory about bringing all of this together. So what does it actually look like? What we're looking at here is the collaboration hub. The collaboration hub is where we're bringing together all of those different data sources that we spoke about. It's where we're managing the geometric data, the document data, where we're bringing the spatial data together, and also the virtual reality data. We have all of the issue management done here. We have the clash detection, and we're also able to link in with the civil tools as well. So when you click on something within the 3D model, for instance, you actually get the alignment, so both the vertical and horizontal alignment. And then within the civil tools, such as OpenRail, you can actually make a modification within a schematic. That schematic is then mirrored within the 2D drawing, which is then represented in the 3D drawing that you can then connect through to your issue, that you can then send that issue through to another party to go and resolve. So again, complex, highly integrated workflows.
Just to point out, this has been built from scratch with HS2 and Bentley. This is from a client organization. This is almost unheard of, to have this level of control and access and understanding of project data at this level of detail is there's not many people doing this, if at all, at this level, which is really really impressive.
Thank you, James. And the next thing I'd like to give you a glimpse of is something called the Visualization Hub. What you saw previously was highly complex engineering data. The HS2, the team recognize that has its place for the engineers, but what we also need to do is to democratize that data, to actually make it easier for people to access, rather than having to hunt around in lots of different systems trying to find stuff. Within the Visualization Hub, we can bring data together from all those systems that I mentioned. So previously, you have simple searches, which allows you to search for a document, search for a model, and also work out what is related to that particular document or that particular asset. So being able to go and find it, so go to the model, as you can see here, start to interrogate that model using all of the tools. Sorry, not all, a subset of the tools that you would have within an iTwin viewer, for instance, and then to being able to interrogate it to a level which is appropriate. And if you need to have more information, you can then click on the icon, and then you launch the particular engineering application. And this has all of the assets. This has a link through to all of the assets and all of the documents that are held within all of those subordinate systems that we spoke about previously. Over to you, James.
Thank you. This is a great video. This is stolen with pride from our colleagues at Align, which is one of our joint venture partners. They've built the Colne Valley Viaduct just north of London. This is a 4D planning and visualization animation where they're showing us essentially how they've created the precast segments for the viaduct and how they're going to be moved from the on-site factory, or the flying factory that we have on site, and move those segments through to implementation out onto the line of the route. The one thing the video doesn't do justice with is just how big those segments really are. They are absolutely ginormous, and every single segment that you see on screen and every single segment in real life is a unique piece of concrete. No one segment is identical. They are all the same, but they are created, formed, and installed on site within that environment. And the visualization tool that the great team at Align have put together shows supply chain stakeholders, management, other colleagues, just how they're going to build and install these segments across that viaduct. And you can just see that green dotted line on the screen, just how long and complicated this viaduct was, and how much risk was involved in terms of the actual constructability of the viaduct, which I'm proud to say it's actually completed now. If you go onto YouTube or go onto the Align website, you'll see some fantastic imagery just showing just how big and how impressive that viaduct is. But it's a really great way to help bring in all of that data that Andy and I have shown you so far into environments like this to understand exactly what we need to do in terms of constructability, what the risks are, timelining, programming, and so on. It's all being pulled from the same data set, which for those of you that work in the industry know that's a nice to have when it comes together in this level of quality and confidence. It's really great to have because it shows us just how much risk we can really pull out of the project and how much finality we can have in terms of delivery. So it's a really great film to see.
Okay, so having built like an asset, or as you're actually going through the construction, the process, it's also important to understand where are we and to actually capture that snapshot. There is a lot of photographs, a lot of drone footage, a lot of aerial photography taken on the high speed to demonstrate to people where are we, what work has been done, to demonstrate the completion of works for contract purposes and all sorts, as well as part of the actual some major surveying that's ongoing. In order to manage this quantum of data and the complexity of that data, a platform has been constructed for these reality data, which is called VAMP, which has allowed us to bring together all of the photogrammetry, the LiDAR data, and also the mesh data into a single platform, which we are then using to augment with our iTwin and the other data sources as well. So you can actually overlay what has been done at the various stages, and also when the scheme is or the asset is concluded, that's also scanned, and you have all of that data which we can also start to work off. James.
So it's a bit of a whistle-top tour. It probably doesn't feel like it. There's a lot of information to take on board, but there's a huge amount of benefits that we can draw from what we've seen today. And I'll let you read those in detail. But ultimately, standardized way of working is an absolute given. If we can make as much of what we do standardized, and of course, it makes it a lot easier with ourselves, our supply chain, and the next stage of the project and project maturity, clarity and visibility. Understanding how to close out issues, how to understand risk, how to communicate with our partners and our supply chain is really, really important. You can only do that when it's controlled. Having controlled environments in any project is of paramount importance, and of course, it becomes more important when the project becomes more complex and more convoluted in scale. Having verification processes for our data, that's really important, whether it's about security, whether it's about permissions. Knowing who accesses that at the right time in the right place is absolutely vital. All of those items above, helps you reduce risk and time and cost, and feed that back into the project, or feed that back as a saving or as an efficiency. It enables easier, better, faster decision making. We know this, but this is us demonstrating that we can and we do this, within our project, and it is possible with other projects as well. What it does do is it gives us opportunity to have better integration in our project going forward, and other projects that we work on, taking those lessons learned and really embedding them into the next phase and stage of the project really helps you improve and really make stuff a lot smoother and easier to manage going forward as we deliver the rest of the project.
Thank you, James. And we wanted to leave you with 4 takeaways. So four key messages. So the first one is: describe, standardize, digitize, and optimize your processes. First and foremost, you really need to understand what is being done in order to leverage the benefit, particularly at scale where you need to industrialize it. The next one is that we need to build the people capability. We need to reinforce that messaging as people onboard onto the projects, and also just to remind people who have actually been on a project for some time and make sure that we're embedding those change agents. The third point is to have a systems engineering approach to having clarity over the data that is required, including that as part of the procurement process, and then assuring it. And then finally, get this early release of value through sort of leveraging strategic partners like us and like other technology vendors to sort of really leverage the sort of value of the data and information that you have. And that concludes our presentation. Any questions?
Thank you.
Thank you for that excellent presentation. Now let's move on to the Q&A session. We have some questions. Let me just get back my screen. Are you seeing my screen now?
Yes.
Perfect. Thank you so much, James and Andrew. I would like to ask you first, what was the biggest, for both of you, okay? Feel free to answer. What was the biggest technical challenge in delivering this vision, and what costs may be related?
I think for me, if I may go first, that the biggest technical challenge was there's a couple of streams to this. So first off, we're a client organization, so we don't natively have these tools at our disposal that we're used to. So we as a client have to become upskilled and prepared and open to using them to understand what's coming into our organization, so we can make those decisions and have those conversations with our supply chain. The next one is knowing how to ask for those requirements, how to ask for the outputs we're going to get from our supply chain. And then it's the understanding of what our supply chain is going to give us and the tools that they're going to use. Not that we are specifying tools, we're agnostic as an organization, but the more understanding we have, the better chance we have of success of bringing those different data sets together, whether it's drawings, documents, PDFs, and all the other stuff that goes into models and so on. If we have a clear understanding at the beginning, we have a really good chance for success as we progress. I think it's that, I would call it dialogue, really, having that sort of understanding and that capacity for dialogue, whether it's with our supply chain or our suppliers, so whether it's contractors or whether it's the Bentleys of the world, knowing that we can talk to each other and go, how do we resolve these challenges? How do we resolve these problems? Or what are the opportunities that we can work on collectively to deliver a really robust and considered outcome for the good of the project?
Shall I give mine now?
Go on.
Yep. So building on what Sir James has said, from our perspective, it was making sure that the manner in which these requirements were given, we were able to consume the data that was conformant. It wasn't always conformant, so building the rules engines that actually sat around in order to do the verification, but also to being able to handle edge cases, be fault tolerant, and being able to make those connections at scale across all of those different data sets, I would consider would probably be our number one challenge. And the second one that I would mention is all around version control, which sounds a bit academic, excuse the pun, but we need to make sure that we understand what the versions are of all the different softwares that are being used within the entire ecosystem, and making sure that we can all play nicely. And when one party updates their particular version, that we can actually manage any changes that may be introduced as part of that process.
Great, thank you. And let's see. So if you were to start this journey again, anything you would do differently?
Do you want to go first, Andy?
Thank you. I would encourage being even more specific on the data definition right at the get-go, and making sure that the definitions of the engineering data, the program control data and other associated data, and the relationships between those data sets was unified within a framework, because that then allows you to move across all the different data sources far easier. I think that's my biggest takeaway within the time that we have.
I think for me, it's capability and requirements. I think, understanding clearly what your requirements are, which is an easy thing to say. It's a hard thing to implement, and you have to be very clear about projects of this size, or any project for that matter, what you want at the end of the process. It isn't just a 3D model, it's all the other information sets that come with it that you need to bring on board. And ultimately, the people that are involved at the end of the project are nowhere near the conversations at the beginning. And it is very much a case of understanding what those requirements are and need to be, and have them clearly defined, or if not clearly defined, have an understanding that you're going to have to define these at some point, and you may have a pain process to go through, or you're going to have to just accept that there'll be problems later on, and that's not a healthy way to start a project. I think you should really be clear about what you want, and understand that lessons learned can be taken from any type of project. We've looked back at other big infrastructure projects for lessons learned, and really sought to seek out where we can remove pain and really embed positive ways of working. And even from within our own stages of the project or phases of the project, we have feedback loops where we'll look at what worked and what didn't work to see whether we can improve next time. And especially within our rail systems contracts, we've really taken some really strong and bold strides to make sure that we're very clear and not moving from those requirements when we talk to other members of our organization. These are critical to success for what your teams are going to need in the future. And then it's capability, making sure that the people you're working with, your supply chain, your suppliers, your partners, your consultants, they understand what is required of them and what they're going to need to do through the process. And that's partly why we've set the upskilling website up, to make sure that language becomes common, that the skill level has a baseline in which we can improve upon or build upon. So it's very much understanding or knowing that capability has to be there from day one. And if there are gaps, work with the supply chain to fill them and support what you need from them to grow and deliver the project properly.
Perfect. So, and that brings us to the close of the track 02. James and Andrew, do you want to leave a message to our audience?
Andy?
Yes, thank you everyone for joining us. Hope you found it useful. Please reach out to us if you have any questions. I think it's fair to say, James, we're both scholars and fellow travelers here, and I don't think any of us think that we know all the answers, but it's just nice to understand what other people have done, their experiences, and so build that all together.
Agreed. It's a privilege to be able to talk and share about the work that I do with this organization. I don't often get a chance, and working with great members of supply chain and suppliers is also fun, because you get to bring out some really good results. And my sort of closing speech is thank you for joining, and please just keep asking questions of your supply chain, your partners, your clients, whoever you're working with, about how to improve and how to get the best out of the systems and tools and requirements you're being charged with delivering. It's a really great part of the industry to work in, and please keep championing the digital piece within whatever industry and business you're working in.
Perfect. So I hope you enjoyed today's session and leave inspired with new ideas and goals. Thank you, James and Andrew, for sharing your experience and insights with such clarity. And we also want to thank our sponsors, Ecotech and BIM Community. Oh, sorry, I didn't pass the PPT now. We want to thank you, our sponsors, Ecotech and BIM Community, and our institutional partners, CIOB, CIAT, Smart Cities Council, NEMA, and BIM Corner. Stay curious, stay connected, and see you at the next ZIGURAT event. Thank you so much. Bye-bye.
Thank you, everybody.
Bye.